Hello and welcome. Today we are going to explore a fascinating question. When will the next ice age occur on Earth? We'll first look at the history of ice ages, when they happened, how long they lasted, and what effects they had. Then we'll ask, could humans survive the next one? And finally, we'll examine how modern climate change is affecting the timing and dynamics of the next glaciation. By the end, you'll have a strong overview of the processes, the uncertainties, and what it all might mean for us. Let's begin. First, what is an ice age? In geological terms, it refers to a long period when large ice sheets exist on land in the high latitudes. Importantly, we are currently in an ice age state because we still have significant ice sheets on Greenland and Antarctica. We're just living in a warmer interglacial phase within it. These cycles of cold glacial periods where ice sheets grow and warmer interglacial periods where they retreat are driven by changes in Earth's orbit and feedbacks in our climate system. The key orbital mechanics are often called the Milankovitch cycles. These are variations in Earth's tilt, the shape of its orbit, and the wobble of its axis. Together, they change how much solar energy reaches Earth, especially in the high northern latitudes during summer. This is crucial because it determines whether winter snow melts away or accumulates year after year, eventually forming massive ice sheets. So, let's look at the history. Earth has gone through several major icehouse periods over hundreds of millions of years. For example, the late Paleozoic icehouse lasted from about 360 to 255 million years ago, but the one that's most relevant to us started about 2.6 million years ago at the beginning of the Quaternary period. Since then, Earth has been in a regular rhythm of alternating glacial and interglacial cycles. For most of the last couple of million years, these cycles have repeated roughly every 100,000 years, though earlier on, they were closer to 41,000 years. This shift happened about 1 million years ago in what's called the mid-Pleistocene transition, leading to longer, more intense glacial periods with much larger ice sheets. During a glacial maximum, these vast ice sheets would cover much of North America, Northern Europe, and Asia. This locks up a huge amount of water, causing sea levels to drop significantly, and the global climate becomes colder, drier, and dustier. The most recent glacial maximum, or LGM, peaked around 20,000 to 26,000 years ago. At its height, about 8% of Earth's surface was covered by ice, and sea levels were about 125 meters lower than they are today. Imagine coastlines extending far out into what is now the ocean. Then the Earth began to warm, the ice sheets retreated, and we entered our current interglacial period, the Holocene, which started about 11,700 years ago. These cycles dramatically reshape the planet. They trigger massive climate changes, force the migration of species, including our own ancestors, shift vegetation and habitats, and carve out new landscapes. Large parts of Canada and Northern Europe were completely buried under ice, which obviously had a huge impact on human settlement and movement. In short, Earth has undergone many glacial cycles, each lasting tens to hundreds of thousands of years. We are currently in a relatively warm interglacial that has lasted about 11,700 years so far. This brings us to the big question: when is the next ice age likely? To trigger a new glaciation, you need a specific recipe. Primarily, you need cooler summers in the high northern latitudes so that winter snow doesn't completely melt. This is driven by those orbital Milankovitch cycles. If the summers aren't warm enough, snow accumulates, compacts into ice, and an ice sheet begins to grow. Based on these natural cycles, what do scientists predict? Well, some research suggests that without any human interference, the next ice age could begin in about 10,000 to 11,000 years. For instance, a recent study estimated that Earth should naturally start its next phase of glaciation in about 10,000 years. But here's the twist. Many scientists argue that because of the massive amount of carbon dioxide we've pumped into the atmosphere, the next glaciation is very unlikely to happen in the next 50,000 years, or possibly even longer. A key study found that if atmospheric CO2 stays above 300 parts per million, a new glaciation is unlikely within the next 50,000 years, and we are currently well over 420 parts per million. Other research from 2016 suggested our emissions could delay the next ice age by 50,000, maybe even 100,000 years. The timing is uncertain because it depends on a complex dance between orbital cycles. greenhouse gases, ice sheet dynamics, and ocean-atmosphere feedbacks. Human activity, especially our CO2 emissions, has fundamentally changed the baseline. The CO2 we've released will remain in the atmosphere for tens of thousands of years, disrupting the natural schedule. So, what's the best estimate? Putting it all together? The current scientific view is this. If humans weren't around, or if our CO2 levels dropped back to pre-industrial levels, Earth might start a new glacial period within about 10,000 to 12,000 years. But because we've already altered the climate system so much, that start date is likely delayed by tens of thousands of years, perhaps 50,000 to 100,000 years, or even more. The next major ice age is not something we need to worry about on any normal human timescale. So, what would an ice age mean for us? Could we survive it? In a major glacial period, ice sheets would once again expand over large parts of North America and Europe. Sea levels would drop, and the climate would become colder and drier. This would have huge impacts on human populations, forcing migrations, changing where we can grow food, and transforming ecosystems. But humans are incredibly adaptable. We already live in a wide range of climates and have the technology to handle extreme cold. So, in principle, yes, we could survive. However, a full-scale ice age would present enormous challenges. Our agricultural zones would have to shift dramatically. Many of our major cities would become uninhabitable. And our infrastructure, built for today's climate, might fail. While our advanced technology puts us in a better position than our ancient ancestors, it would still be a monumental challenge. But here's the ironic part. Our current actions might be what's preventing it. Our CO2 emissions are delaying the next ice age. So the question is inverted. Instead of preparing for an imminent ice age, our current challenge is global warming, which is actively pushing the next glaciation further away. This delay is a side effect of our activities, not a planned strategy. This highlights the powerful role of CO2 as a climate control knob. We know from ice cores that during past glacial periods, CO2 levels were much lower, and during interglacials, they were higher. CO2 amplifies the subtle changes from orbital cycles. The temperature difference between the last glacial maximum and today was about 4 degrees Celsius globally, and CO2 was a major driver of that change by raising atmospheric CO2 from about 280 parts per million before the Industrial Revolution to over 420 today. We've pushed the climate system far off its natural course. As that one study pointed out, as long as CO2 remains high, glaciation is off the table for a very long time. But it's critical to understand this. Delaying an ice age is not a good thing if it comes at the cost of dangerous global warming, rising sea levels, ecosystem collapse, and extreme weather. While the next ice age is far off, the climate crisis we're creating right now is immediate and urgent. For policy and planning, we don't need to prepare for an ice age anytime soon. We need to deal with the warming we're causing now. The fact that we can alter geological cycles shows just how powerful our impact on the planet really is. To summarize, Earth has experienced regular ice age cycles for millions of years. Under natural conditions, the next one might have started in about 10,000 years. However, due to human-driven CO2 emissions, that timing is likely pushed back by tens of thousands of years, or even more. While humans could likely survive such an event, our more immediate challenge is the climate change we're causing right now. In short, the ice age alarm clock is set for the distant future, but the climate change alarm clock is already ringing loudly. What do you think about the timing of the next ice age? Let me know your thoughts in the comments. Should we focus entirely on near-term climate action, or is it still worth thinking about these long-term geological cycles? If you found this insightful, please like, share, and subscribe for more past, current, and future events in our world. Thanks for watching.